Hello and welcome back again. This is Ms. Bushra with you. We're back again for another lesson. Today is our third lesson for section 1 of chapter 2. So we're going to talk about cardiac cycle. We learned about how the heart is working and it's beating and contracting and how the electrical impulses work from the AV node and the SA node. Now, today we're going to talk about how each beating have phases. And we call it together the cardiac cycle. All right? If you see here, we have almost 3 phases. And among these phases, it takes about 0.8 seconds to complete from here to here. Now, let's see why 0.8 seconds. See, a minute is 60 seconds, and if you divide it by the average times of beating of a human, which is 75 times per minute, you get 0.8 seconds for each beat. So this takes about 0.8 seconds. Remember that. And it's divided between 3 phases because, see, this word systole means contraction and this diastole means relaxation, because the auricle, which means atria, but auricle means like very small ears. When you look at like an anatomical art, you will see the atria looks very small and they name it like that. So it's another name for atria. And you see the ventricle separated from each other. Their timing was delayed. If you remember that the timing of the ventricular contraction was delayed by the AV node. So it split the contraction into 2 phases. Hence, if you look at it, the cardiac cycle is almost 0.8 seconds. The systole, which is the contraction, takes about half, and diastole takes the other half. However, they are not equally divided between the auricular systole and the ventricular systole, since like the ventricles are very big and the walls like very long. So it takes about 0.3 seconds, while the auricular systole takes about 0.1 seconds. This is about timing. Now let's learn what's happening during each of these phases of the cardiac cycle. The first phase, which is the auricular systole, is where the atria are going to squeeze, okay? They pump the blood. Once that happens, the blood is going to be pushed down to the ventricles. See, the blood flows from atria to the ventricles. These are 2 atria and these are the ventricles, all right? Now, both atria do that at the same time. And if you remember, between atria and ventricle, there is a valve, like a door. And they need to open up to let the blood flow to the ventricles. What do we call it? The AV valves, tricuspid and bicuspid. They need to open up. However, the AV valves and the SL valves are opposite from each other. So when these are open, these are closed. They were closed before. So we just say that they remain closed like that. We talked about this and this and that very easily. Very easy. You can like imagine it. Now we're done with the auricular systole. Let's come to the ventricular systole. Now the ventricles are full of blood. So when it's squeezed, it needs to push the blood out to the whole body, to the lungs and to the body. So when that happens, both ventricles contract at the same time, and the blood flows from the ventricles into arteries, aorta and pulmonary artery. Remember, aorta and pulmonary artery. And we know something, that the SL valves are at the base of each artery. So the aortic valve and pulmonary valves are there. They need to open to allow the blood to pass, right? There you go. They need to open to allow the blood to pass. And we know that they have to be opposite, so the AV is going to close. See, open doesn't create sound, but closing creates sound. There you go. There is a loud sound created because of the closing of tricuspid and bicuspid valve. During which stage? The ventricular systole. Remember, it lasts about 0.3 seconds. We're done with the contraction part. The blood now is out. What should we do? We need to refill the heart. So the heart as a whole, both ventricles and both atria are going to relax. Okay, both atria and both ventricles are going to relax. During that relaxation, what's going to happen? See, blood flows back to the atria, fills them, so that it's going to send it back to the ventricle later, because the cycle is going to repeat. All right? Remember, if heart relaxes, it pulls blood. But the atria, okay, the atria, when it gets filled from the veins. However, ventricles should not open the side with the artery. The arteries already took the previous batch of the blood. We should block it so that that one that we send, it doesn't come back. We don't want them to come back. So this time, the semilunar valve, aortic and pulmonary, are going to close and create another type of sound called dub. Remember, lub is the closure of atrioventricular valves, while dub is for semilunar. This happens during ventricular systole. This happens during diastole, which is the relaxation of the heart. At the same time, the atrioventricular valves are opened. That's it. It takes about 0.4 seconds. So the whole thing happens. These 3 stages, it's one beating of the heart. It's 0.8 seconds, and it's one cardiac cycle. Lastly, I did not talk about this, the waves. What is that supposed to mean? See, in hospitals, doctors are measuring the activity of the heart with different methods. One of the methods is ECG, which probably most of you saw this already. And another one, you saw it in, traditional Chinese or like Asian places where they put their fingers on the wrist, or sometimes when you see somebody checking if somebody is alive by putting the hands on the pulses here in the neck or the wrist. And also another method is probably the easiest one, you saw it, is using stethoscope or directly checking the heartbeat by your ear to check if there is sound. So we have these 3 methods that are used for what? Measuring the heart activity. The one I didn't mention in the table is electrocardiogram. Electrocardiogram, ECG or EKG in UK they call KG, all right, is a test used for measuring what? Changes in electrical activity of the heart. The nodes making these electrical activity, and the reading of that, you're going to see it here. Now, what you're going to see is this. I'm going to redo this one. One bump, and then a straight line, very short one, and then goes down, up, down, further down, and then something like that, and then another bump. This is called P. This is called Q, R, S, and T, like that. They are divided based on the cycles that we studied in the previous page, the cardiac cycle stages. The P stage represents the auricular systole, while the Q, R, and S is the longest here. They represent the ventricular systole. However, the last one, it shows the relaxation of the heart, the diastole, like that. Hello? Now, this is very essential in the hospitals. The distances of each beating is important. The shape's supposed to be like this if somebody is normal. Any of these things are missing, any of these picture or like the graph have any abnormality, that means the person have a problem. So they are studying in various ways, and it helps the doctors to detect any problems with the heart. So ECG is a method. Remember, I put all of it here too. P is for auricular systole, QR is for ventricular systole, and lastly T represents the diastole. Now, pulse taking. Pulse taking, you take the heartbeat, or you measure the heartbeat working from the arteries. See, when the arteries are connected to the heart, especially aorta, it has a high amount of pressure on the walls. And that pressure on the walls You can clearly sense it under your wrist. If this is a pressure sent during a ventricular systole, you see, you feel it when the walls are pushed. That's why, look at your left hand near your thumb, then here, exactly at the wrist, you put 2 fingers and you will start feeling the pip, pip, pip. What is this? This is the smaller artery that branched from the aorta, and it's called the radial artery, and you can feel that pulsating pressure that was caused because of the ventricle contraction. As long as the beating you feel it here, or the pulse you feel it here, that means the heart is healthy and it is beating. Okay? Another thing is checking the sounds of the heart. Now, the sounds, we said that the lub sound that was created during the ventricular contraction and the dub sound that was created during the diastole, they are the sound of closing valves, and they're different from each other. The lub sound is longer and lower pitched, while the dub sound is shorter but it's higher pitched. Okay? And we said that in which cases, okay, they were, okay, in which stages of cardiac cycle they start, and what is the cause of it. This is because of AV valve, and this one is because of the closure of semi-lunar valve. Remember, these valves are very important. If anything happens to the heart, okay, it's called relapsing or heart murmur, okay? The sound of the heart will change. For instance, in heart murmur, the sound changes because of the backward flow of one of the valves, all right? See, if one of the valves are not closing properly, the sound is going to change. And once that happens, that means there's a problem with it. One of them is heart murmur. Again, I will repeat it. Heart murmur is a problem in the heart valves. It changes the sound of the heart. Write this as a note. We're good. We learned about the electricity, everything, and we learned about the cardiac cycle. Now, we're finished with the core, the heart and what it's doing. We're going to the vessels and how they take that precious blood to everywhere in the body. So vessels are of 3 types. Until now, we studied only these 2 because these are the ones connected to the heart. However, the third one, capillaries, you can see it within the tissues and organs, all right? It's very important because it's the only place or only vessel that passing down materials or exchange of materials happen in it, okay? That exchange of materials occur through it. Tamam? The other 2 are just like highways. You cannot stop them. They cannot do exchanges of material. Their cell wall is super thick. But this one have like the wall of their vessel is very thin. So there is no problem of exchanging. And the blood is very slow compared to the arteries or the others, okay? There is one more thing. The system in our body, the cardiovascular system, it's called closed system. Because when the vessel starts from the heart and it goes to the other place, it is never going to be cut. It's not open. It's coming one way and goes back to the heart like that. It creates a circle. So it's called closed system because the blood continues to remain between heart and vessels and doesn't go to the tissues, okay? There's also open system. But what is the difference between open system? When the heart pumps it, it goes to the vessel. After the vessels have a dead end where the blood is going to be spilled in the tissue. That's how you know it's an open system. For example, insects are having open system, but animals, birds, those types of things, they all have closed system. Explain the statement. The blood vessels that are part of the closed circulatory system, they create a vast network. Vast means huge. Network means like a lot of branches. So once that happens, it's because that blood, we want it to reach everywhere, because we don't let it go freely within the tissues and then come back later by itself. We need to take the vessels further and further and further so that every single cell of your body is close to a capillary. It's close to a vessel. They can do exchanges and they don't die. It's very, very important. And this way, the blood flows in one direction at all time. It doesn't need to go out. Among the vessels, if I have to draw, let's do it now. Okay, there we go. You see, if their functions are different or the way that they work, that means their structures will be different as well. Let's start here. This is an artery. See, an artery gets smaller and smaller and smaller until it becomes part of the capillary. Okay, this is part of the capillary. Now, a capillary is the smallest and the thinnest, and then the capillary is going to slowly become bigger and bigger and joins bigger vessels called veins. Again, this is capillary and this is artery. So when artery brings blood from the heart, all right, and then it becomes arteriole, that's this very, very small type of artery before it transitioned to capillary. Then capillary joins back to become venule, and multiple venules joins back to become a big vein like that. So the system, it looks like that. Capillaries are always close to cells and close to tissues. Why? Because they exchange materials with the tissue from all sides. All right? If there's a tissue here that doesn't quite get to this capillary, there will be another capillary here helping it out. What's happening here? The blood from the heart comes through the artery, goes to the arteriole, and then here it slows down. The smaller it gets, the less pressure. Remember, arteries have very high pressure. Why? Because they come from the ventricles. And when the ventricles push, the amount of pressure created within the artery is huge. But the more arteries become smaller, the more pressure they lose because of the resistance of the wall. And once they become part of capillary, the pressure is much lower. And of course, the speed is way less. So when it goes back here until it gets to vein, there will be very low pressure of blood. Tamam? Again, that's how the blood goes. Here it slows down and creates exchanges. Okay? What happens in the exchange? See, oxygen is going to go, let's change the color. Oxygen is going to go to the tissue while CO2 is going to the capillary. Also, nutrients go to these cells while waste product is going back to the blood, which is carried later on by the vein. And the vein, of course, go toward the heart and takes it back. Then this is the systemic cycle, by the way. In the lungs, it's quite opposite. Everything is opposite. But where I'm talking about how these two are working and why the high pressure was created is because of the pushing and contraction and the pumping of the ventricles that create that high pressure. While losing it and becoming low pressure in the vein, it's because of that narrowing it down to smaller and smaller vessels that is going to make sure that it's slowing down and losing a lot of pressure. The idea here is that the arteries are very large, by the way, and muscular. There is huge amount of smooth muscles, like about 40 layers sometimes of muscle tissues here. And of course, the outside is covered with connective tissue, and the innermost part of it is endothelial, the epithelial that we studied from chapter 1. See, it carries away blood from heart towards the organs. It has high blood pressure. Why? Because it's connected to the ventricles, and the ventricles push it there. Why there is no valve? In the structure of the artery, you don't need valve. Why? Because the blood moves so fast with high amount of pressure that there is no chance of going back. It's high pressure and speeds very high. Okay, so it doesn't go back. No need for the valve. Then there is thick wall. Why thick wall? 3 layers here and thick wall. The thickness of the wall, and there's another thing, not only thick, it's elastic. Thick plus elastic. These two is going to allow it to endure a lot of pressure, okay? High amount of pressure. That's why. There you go. It can stretch and prevent the arteries from bursting. Let's draw an artery here. This is an artery. When there's a lot of pressure on the walls, instead of bursting, the wall is going to stretch and open. Okay? Making sure that it's adjusting to that amount of pressure. Okay? But of course, it has a limit. It's not limitless. At one point, if it's outside of the normal, then it might not help it. The biggest artery in the body is aorta. All right? And all of the arteries in your body, other than the one in your lungs, are branching off from aorta, by the way. Okay? So the pressure is coming from that. Once they branch, they become arteriole. Arteriole means like small arteries. It says, how is the structure of the artery held to this function? Like we said, the stretchiness and the thickness, it doesn't let it burst when there's high amount of pressure. But let's see, what is blood pressure? It's the pressure within the arteries. Don't forget about that. We're talking about artery. The force that blood exerts against inside walls of the blood vessel. If you have a blood vessel like that, okay, that's an artery. That force on the walls on each side, what do we call it? We call it blood pressure. See, everybody knows about blood pressure, and we checked it from our arm like that here for various reasons, right? Because there's a lot of reasons. Person's diet, person's health, age, they might change. And why is it important? We're going to learn it soon enough, all right? That force was created by ventricles. Don't forget, arteries don't create the pressure by themselves. They carry it from the ventricles, all right? So, the contraction of the heart moves the blood through these arteries with great force. The 2 main arteries with highest amount of pressure, of course, is the one closest to the ventricles. They receive it immediately with high pressure because later on the pressure is going to be lost with the movement. Okay, how is blood pressure measured? From the arteries in your left arm especially. Okay, here. Now, there are of 2 types. You see, sometimes your grandma, for example, is sick. They say, oh, her blood pressure was 14/9. And that's, sounds something serious for some of reasons. How do you know about this? You need to learn how this works. There's 2 types of pressure from 2 different stages of heart, both connected to ventricles. We don't talk about the atria because pressure is created because of ventricles, not atria. See, when the ventricles push, they create systolic pressure. Look, ventricular systole is part of heart cycle. Systolic pressure is the pressure created because of that certain stage, okay? Now, it happens because the ventricle, especially the left one, because every part of our body that we measure comes from the left cycle, all right? It creates a pressure of 120 millimeter mercury, like that, in the males and 110 in females. However, heart is not always in contraction, it's also relaxing. When the ventricles relax during diastole, the amount of pressure changes in the arteries. It becomes 80 for male and 70 in female. And the way that our measurement device is reading, they put the systolic over diastolic like that, okay? Like this. So how you're going to read it? That males have a normal blood pressure of 120 over 80, while in females is 110 over 70. However, you never heard of these huge numbers. You heard of 12 over 8, 11 over 7. That's because they reduce it, the zeros, so that the huge numbers are not going to mess up with the people's mind saying, oh, it's 10 points difference. No, it's smaller. The changes are small. So they made it into smaller numbers so that people don't panic when they read like numbers like that. So remember, in systolic pressure and diastolic pressure, we're going to put the systolic over diastolic. That's how we're going to read it. And there is a whole table about the differences between these two. During systolic pressure, the first sound created, that's because some doctors are using not devices like electronic device, but rather the stethoscope, and they put it here, the other end, and then pressure it, then release it. They create sound. Once they hear the first sound, they mark it as systolic pressure. And when the sound no longer they can hear it, it's called diastolic point. Basha? That's how they read it. Of course, systolic pressure is connected back to the ventricular systole. So anything happens during ventricular contraction or systole, they share it with the systolic pressure. And diastolic pressure happens during the relaxation of the heart, included with the ventricle relaxation. Everything that we studied in the table on the third row, it's written back here. All right, and we mentioned those. Hypertension. Hyper, it's a suffix, means above normal. Tension means pressure. Pressure above normal. High blood pressure. That's what it means. High blood pressure is something that a lot of people suffer from, especially elderlies. And the first thing you hear it is that they need to reduce the amount of salt. And of course, high blood pressure is not only in cases of diseases. Sometimes a person's high blood pressure increases because they have like their heartbeat increases because of they get scared or something like that. It happens. And throughout this book, we're going to learn a lot of times when the heart pressure is increasing. Okay, and we're going to write it again. Why hypertension is leading cause of death in many countries? See, if the blood pressure is too high, more than normal, remember when we said that the elastic wall of the arteries are going to expand? They might not withstand it, and they might burst. That bursting is causing what? Heart attack. And this is what kills a lot of people. Okay, let's see. Capillaries and veins. See, the transition from artery is not immediately to vein. There's capillary between them. It's like a transitional path. Here is all exchange happen. Arteries and veins have thick wall, no exchange of gases and nutrients happen here. Okay, we studied about this, aorta, smaller arteries, and arteriole, and then capillary. We studied about that. Let's learn about capillary. All right. Capillary in diameter is the smallest among all the other vessels, all right? And not only they are small, if I draw a capillary, remember the endothelial layer we said in chapter 1, one single layer of flat cells? They have just this, endothelial, single layer, flat cells. That's how they are. Is there any muscle? No. Is there any connective tissue? No, certainly not. And this is helping them with their function. How? Because if they have like a very thin wall, things easily pass by diffusion in and out. in and out. Remember, diffusion is when they are naturally going from high concentration area to low concentration area. That means if there is a lot of oxygen here, the oxygen goes out. If there is a lot of CO2 here, the CO2 goes into the area where there's less CO2. Okay? That's making diffusion easier. Remember, one cell thick. They create a network. That means their numbers is huge. You cannot count it basically. Alright? As they're extensive, going everywhere in the body. Alright? They're always close to a tissue. Okay? They're always, you have a tissue here, there's a capillary here, there's a capillary here as well. Alright? And this helps speeding up the exchanging. Alright? Having like very thin wall, having extensive network, this speeds up the reaction. Alright? And the diameter is small. Remember that. To an extent that sometimes, let's extend this. Oh, I changed the color. Sometimes a capillary is so narrow that it allows only one red blood cell at a time to move. You cannot put two red blood cells at the same time. And this is what it means when we say single file. Single file means they are creating one line, like that. All right? This picture of capillary, you should know about it. This represents the capillary, and this is one single file of cells. Remember, we have endothelial cells. The capillary is one cell thick. Can you find muscle? No. Can you find connective tissue? No, you cannot find it. The exchanges here, by the way, happens because of the concentration differences of materials. If there is high concentration of something here, like oxygen, okay, or CO2, high CO2, it goes to area of low CO2 and vice versa. Every single material moves down their concentration gradient. All right. We're down to our last vessel, the veins. All right. Now, the veins are going to receive blood from the capillary to take it back to the heart. Now, the capillaries reduce the speed of the blood and the pressure of the blood. So, there's no need for a very thick elastic wall like how we needed in the artery. What do we need here to prevent things from flowing back, the blood? Because apparently the high pressure was keeping the blood from the arteries to keep going on. Here you don't have that. That's why you will see that the veins are large also, but it's not muscular, or at least not as thick. Okay? Lower blood pressure, and this lower blood pressure what causes the valves to have, the veins to have valve. So when you draw, anytime I draw something like that and I show you the valves like that, it's a vein. There's no question, okay? You see it here too, like that. All right? The veins are composed of 3 layers. That's a similarity between vein and artery, by the way. All 3 layers are the same. But the difference is it's thinner and less muscular. There is muscle, but thinner, okay? And you see endothelial, muscle tissue, connective tissue, all the same. There's no difference between them. The only thing added is valve, and it's thinner, less elastic, less muscular. Why? Because it's low pressure. That's why. There you go. Because of low pressure, there's valve. What is the function of valve? Preventing blood from flowing backward. We have pulmonary vein, inferior vena cava, and superior vena cava. The only one with an oxygenated blood is pulmonary vein. These two have deoxygenated blood. This is bringing blood back from the lungs back to the heart. This is from the body to the heart. But the difference between these two, they both take it back to the right atria. But the thing here is that one brings it back from the inferior, from the lower part of the body, and the other from the upper part. This one, however, takes it back to the left atrium. There you go, an illustration from the original book that I brought it. It shows how the arteries and veins share same layers. However, okay, the capillaries has like, you know, it's a transition between both of them. And this is it for today's lesson. Inshallah, we're going to continue in our next lesson, the patterns of circulation.